Hello and welcome to this CATIA prismatic machining instructional video. In this video we are going to talk a little bit about process planning, that is, how do we go about deciding what machining operations need to be performed to generate the shape that we want. If you've been following these videos, you would have completed all the machining for setup 1. This is the part here that we've been working with. Setup 1 is the underside of the part. If you recall, you did a facing operation, some engraving and chamfering. We now need to proceed to setup 2, which is basically to flip the part around and then to machine all the material away from the stock to leave the design that can be seen through the transparent stock. So let's step through the process of identifying the operations. Let's, for the time being, hide the stock. And if we look at the geometry we want to generate, there's obviously a lot of holes that need to be machined at some point in time. There's also profiling. You've seen the profile operation in the first setup. We use that for the chamfer and also for the underside of the part. This material here would probably be removed using a profiling operation. And then we get into these regions here, which are generated using pocketing operations. We haven't looked at that operation yet, but that's definitely something that will be needed here. So to remove this material here, as well as to remove this material in this pocket here. So let's look at how some of these volumes, how some of the material that you are going to remove would map to different types of operations. So for example, if we look at the part edge on, we obviously see that there is some material, as there was in the first setup, that needs to be removed by facing. So what we would probably start off with is a facing operation. And I've highlighted this in green, which removes material from the top of the stock down to the highest point of the part. So that would be our first operation. Typically facing is done first. Following facing, there are a number of choices that one can make in terms of what the next operation might be. One can, of course, possibly machine in this region here, but again, let me draw your attention to this this step or flange that runs around the entire boundary of the part. It might be a good strategy to use the profiling operation to remove this material on the outside first. So let's go ahead and do that, or let's visualize what that would look like. So this green boundary or green outline here shows the final surface that one would generate by the profiling operation. Now it does not go all the way to the top of the stock, because remember we've just removed that using the facing operation. And after the facing operation, we're going to go ahead and remove material on the sides using a profiling operation. Following the profiling operation, we now need to start thinking about pocketing. So we have a choice as to whether to machine in this region first or over here. There may be reasons in terms of efficiency for doing this. Also, one of the things that one needs to consider are tool changes. I'm going to hide the stock temporarily. If you look at these pockets, you'll see that there are corner radii on each of these pockets, on each corner, as well as over here. And that corner radius will determine what size cutter one can use. So one might be in a situation where one has to do a tool change depending on what these sizes are and the efficiency one wants to go with. If you want to determine what your tool radius size is, your maximum tool radius size, you can always measure using the measure tool what these corners are. So I'm going to go ahead and switch this to any geometry. So this tells me that I need a 3/4 inch maximum size cutter. Probably would use something smaller than that to generate this radius correctly or fillet correctly. And if I look at the corner down here, again, it's 3/8. So this would tell me that the maximum size cutter that I can use would be a 3/4 diameter end mill. That would mean, of course, that the tool would come to a stop right in the corner, because the radius of the tool matches the radius of the fillet. Typically, we try to move the cutter to the corner without a dead stop, meaning that we'd want to probably use a cutter that has a smaller diameter. So in this case, maybe a 1/2-inch cutter would be appropriate. So again, that's the type of information that you want to start getting at, because that's going to figure into your planning for the tools you're going to use. Also, too, on the outside profile, since that's what we're doing first, it would be a good idea to check the radius of this part of the profile to make sure that it is doable, to make sure you pick a tool that's doable. So let's measure that too and see what we get. So this gives a radius of 0.436, so it's a fairly large radius. So in this case, a 3/4 inch cutter would fit in there. But again, maybe we want to use the same cutter on the outside as the inside. That's also a consideration. So again, getting information off the part in terms of corner radii is really important for your planning. So again, getting back now to our strategy, let's say we wanted to start by machining this pocket here first. If we look at this pocket, we see that there is an island in the middle. And this island, the top of the island, does not extend all the way to the top surface. So if you think about this, this is actually two pockets. There's actually a pocket that starts with this surface and where the bottom is the top of the island. And then there's a second pocket which starts at the top of the island and then machines around the island all the way down to this bottom surface. So what would these look like? So let's look at the top pocket. So it's highlighted in green. So we'd have to create a pocketing operation that does that, removes this material here. And then the bottom pocket is shown again in green. And as you can see, this bottom pocket needs to take into account the fact that there is this protrusion. We call this an island in machining terminology, that the cutter has to work around in order to create the correct geometry. So that would get us the material removed from this pocket here. Once we're done with that, we need to then focus on this part of the stock to remove the material over here. So the way one can approach this, if we look at this, we see that there's also an island here too, which also limits our ability to cut material from this surface here downwards. So in this case, if we consider this a bottom surface, all this material on top of it is actually a pocket in some sense, except that it's an open pocket. This over here is a closed pocket because there's no open walls. But on this region here, with this as the bottom surface, we have actually 3 open sides in which to generate that pocket. So if we look at that, what would that look like? So again, just to visualize, the green here sort of shows you how we might tackle this region here. Again, this is where the top of the material is, still in this region, and we want to remove everything in green to get us down to the top of the surface here, top of this bottom of this pocket. So that's the next step. And then of course, once we've gotten down to the top of the island, notice that there's this region here too, which has to be machined. So we're machining from the top of this down to this ledge here. So we can machine that also as a pocket, an open pocket, with the one difference of course being that the top of this pad here, or protrusion, now becomes an island that we have to avoid as we're removing this material. And then after that pocket's removed, we can step further downwards into the pocket itself. Notice that this pocket has an open bottom. However, there is still part of the pocket that has a floor. So we need to consider that too. So we probably need to machine this using 2 pockets, just as we did for this part of the part over here. So if we machine the first pocket, that needs to take into account the island. So that would look something like this. So we would use pretty much all of these walls as the boundary of the pocket. So this would be a closed pocket, but there's an island in here that we have to avoid as we do that machining. And then finally, we have this open pocket on the bottom, not really open on the sides, but open on the bottom, that we also have to machine. We refer to this as a soft bottom. So that pocket would look like this. And of course we'd have the cutter drop through a bit so that we can get a nice clean edge on the bottom. And that would complete the machining on this side of the part. There is one feature that we still need to do, one feature other than the holes, of course. We're just looking at the pocketing operations or the milling operations right now. Notice, if you recall, we machined this profile. This was our first operation, or second operation after the facing. However, there is this ledge here that goes around this region that we didn't get using this first profiling operation. So we need one final profiling operation to run around this part here, this region here, to get the correct surface that we need. So that would look something like this. So again, the cutter would run around. Notice that this wall here is aligned with the wall of the pocket, but we're really trying to machine this step or ridge that runs all the way around. So again, that's kind of the process that one goes through in terms of trying to come up with a plan to machine this. If we look at all of the volumes, this here displays the volumes that I was highlighting. I'm going to just highlight them all here so that you can see them. So this here represents somewhat of a sequence that one has to follow, starting with the facing operation and working your way down to the various operations or various volumes to get the result that one wants. And again, this is one of the first steps one needs to go through. There are obviously choices here. One of the choices we made was to machine this pocket before this region over here. We could reverse that order, certainly. So there are choices that need to be made, and sometimes you have to go back and redo things because it might be more efficient once you've completed. The other thing that we talked about is making sure you use the right tools. So as you go through identifying the operations, becoming clear about what are the maximum sizes you can use for a tool to make sure you can remove all the material that you want. The other thing that you need to pay attention to is that when we talk about an operation, in this case we're talking about a volume and a facing volume. If we talk about one of the pocketing or profiling operations, there's a roughing phase as well as a finishing aspect too. So you also have to pay attention to what are the finishes that are required on each face of the part and how those play into setting up your various roughing components of your operation and the finishing component. So again, this is a brief overview, a brief summary of process planning, as we call it, machining process planning. And this is one part of it, because of course there are things like the actual speeds, the specific tools you pick, and so on, the machining strategies for each volume that you have to also decide upon. But this is this step here where you figure out how to decompose the stock and come up with a strategy for how to remove it with operations is a very important first step.